Friends, good morning to everyone. We were dealing with the dipole moment. The dipole moment arises due to the unequal sharing of electrons between atoms of different electronegativities. And because of this, the polarity arises in between the atoms of the molecules. And this polarity is transferred to the whole molecule. This is the effect of this disparity in the electrons distribution. You have seen this effect, the inductive effect, in the last presentation. This is a permanent polarization molecule which arises due to the presence of electron withdrawing or donating group at the one end of the molecule. And in inductive effect, it is transferred or relayed through the sigma bonds or sigma electrons. In continuation of this, we are going to deal with another effect which we see because of the dipole moment. That effect is called as resonance effect. It is also named as conjugative effect or mesomeric effect. Like that of inductive effect, it is also a permanent polarization that is induced in the molecule due to the presence of electron donating group or withdrawing group. But however, it differs from the inductive effect in the following fashion. The inductive effect is transferred or transmitted or relayed through the sigma bonds, whereas the resonance or conjugative effect is transmitted through pi bonds which are in conjugation or through lone pair of electrons present on the adjacent atom. This change in the arrangement of electrons brings about various resonance structures which are also called as resonance hybrids. More the resonance structures or the resonance hybrid, more is the stability of the molecule. Let us take an example. The pi electrons moves from the electron donating group or it moves away from the electron withdrawing group. It gives rise to positive resonance or negative resonance effect, which is denoted as R effect, or it is also denoted as plus M and minus M, plus mesomeric and minus mesomeric effect. If I take a molecule in which it has a electron donating group like oxygen, which has lone pair of electrons in conjugation with the pi bonds, this lone pair of electrons on the oxygen is shifted towards the next carbon. Next carbon is already tetravalent. It has to maintain a tetravalency. That's why pi electrons moves to the next position and this goes on. And I will get the resonance hybrid. This is also not stable. This electrons moves back and it gives back the original molecule. It is something like I have excess work, I transmit to the through the system to the whole group so that I am stable. But I think I am stable, but it comes back to me again. There is the sharing of the excess electrons within the system on all the atoms in the system. That's why everything becomes stable. If this is the positive resonance effect, it can be having negative resonance effect or negative M effect when there is an electron withdrawing group. The oxygen in the carbonyl group is in sp2 hybrid form. That's why it is electronegative. It do not have lone pair of electrons. Thus, it is electronegative. Pi electrons moves towards this oxygen. Once this pi electrons moves towards the oxygen, the carbon to which it is attached becomes deficient. To satisfy this electron deficient carbon, the pi electrons from the adjacent carbon moves and I get a carbocation in the adjacent atom. Is this stable? Again, to satisfy this positive, this electrons moves, creating the positive center on this carbon, and this excess electron which has it gained, it again moves. And there is a stabilization or equilibrium maintained between these two structures. This one is the resonance hybrid of the first one, and vice versa. More the resonance structures, more the resonance hybrid, more is the stability of the molecule. This is negative mesomeric effect or negative resonance effect. It is represented as minus R or minus M. The salient feature of this resonance effect is that it do not fade away with the distance. It is, whereas in inductive effect, the inductive effect is transferred through the system up to 3 to 4 carbon atoms maximum. Afterwards, it goes on fading away from first atom to second, second to third, and third to fourth, and so on. But in this resonance effect, this do not fade away with the distance. It carries throughout the system. It can be transferred to any number of carbon atoms in a conjugated system. That is the unique feature of resonance effect which differs from the inductive effect. Here the effect is transferred through pi electrons or lone pair of electrons, and it do not fades away with distance, and for this to occur the pi electron should be in the conjugated system. The plus M effect is seen depending upon the group which is present. O minus have more positive mesomeric effect than NH2, is having more effect than NHR, is having more effect than NR2, and so on and so forth. Similarly, negative mesomeric effect can be seen depending upon the electronegativity of that of the group it is attached to it. In the next presentation, let us look into the other type of effect. Till then, have a nice day. Thank you.